Good evening, everybody. It's John here from Tutor to You, welcoming you along to another of our A-Level Geography live streams. And tonight we are looking at coastal systems and landscapes. I was just reading some of the chat going on in the YouTube window. Catherine was asking, what's your favourite bit of coastline? What's your favourite bit of coastline, Catherine?
Oh, in this country, I've got to say Snorstall Bay down in Cornwall, where my mum lives, and it's just so sheltered and amazing, and you could just have such a great time there.
I have a suspicion, Catherine, that we would get lots of responses about Cornwall if we were to ask that question to everybody. I'm joined tonight by Catherine, as you can just hear, and also Brendan. Brendan, good evening to you. What's your favourite bit of coastline, Brendan?
Oh, it has to be a low-energy coastline, one in North Kent on the Thames Estuary. Partly because it's ever-changing, the tide's quite high range, and there's fantastic sunsets.
Wow, what a reason to pick that one. Thank you, Brendan. And what a fantastic topic for us to cover. Listen, guys, if you've not joined one of these before, massive warm welcome to you. You'll have noticed my little post which says, please do join us by using the chat window. So as our questions come along tonight, please give us your responses. Sometimes it'll be really quick, a one-letter answer, sometimes a little bit longer. We would love to know what you think is the answer to the questions that we're about to use. We will use a little PowerPoint presentation as the backdrop to what we're doing, and that PowerPoint presentation will be available for you to download as soon as this live stream has finished, so look out for that. And of course, this is being recorded, so you can always watch over it again if you want to, and if you are watching this on replay, a big warm welcome to you. So tonight we're talking about coastal systems and landscapes. What sort of things are we going to be covering, do you think, guys?
Well, we're going to be looking at some of the areas of the specification that haven't been examined quite so recently. So it's going to be quite varied. We're going to be thinking about some coastal processes, the high and low energy coastlines, as Brenda was just referring to, different landforms, a bit of the impact of climate change, and of course, mentioning those key case studies for this topic.
Yeah, absolutely. We must cover those case studies. Look out for the alerts when they arrive. Okay, shall we make a start?
Lovely. Right. Okay. So we're going to get you thinking a little bit now with a bit of a bubble quiz. And the way bubble quizzes work is you will see a question and you will see some answers, and you need to say how many of the answers you think are correct. So let's see the first question. Right. Okay. So, which of the following are sources of energy in a coastal environment? So, we've got their currents, winds, waves, and tides. So, you could pop down the number that you think are correct. And then, if you want to, you could also pop down which letters you think are correct. So, let's see the answers. Right. Okay. You are super speedy. Well done. Absolutely zooming through there. So, right. Okay. So, let's see the answer now and see if you've got this correct. Right, fantastic. So absolutely brilliant. So Sam, Izzy, Pranesh, lots of different people there getting those right. So brilliant thinking. On to the next one. Right. Okay. So now we're thinking about wave energy. Which of these are factors in wave energy? So again, you could pop down the number. You could pop down which ones you think are the ones that are the correct answers. Right. Okay. So we've got there a lot of people zooming through. So we've got a lot of people saying they think it's 3 this time. John, should we see if they're correct? Right. Fantastic. So well done. Well done again to Izzy, and well done to Aidan. Absolutely brilliant. Amelia, great stuff. On to question 3. So this time we're thinking about weathering, and we're thinking about mechanical or physical weathering. So which of these is or are associated with mechanical weathering? So again, what number is it? And could you say which ones you think might be right? Oh, we got a bit of variety coming up this time. So Sam's and SOD say A, and Molly saying A, and Roman, Wriggle. Right, lots of people saying A, John. Let's see if they are correct. Right. Oh, well done. Well done there. So fantastic. So freeze thaw there being a physical type of weathering, and the other ones, of course, being associated with chemical weathering. Fantastic. On we go. Right. So brilliant there. Thank you ever so much. And you're contributing really, really well and very quick off the mark. So that is great. So we're looking now at coastal processes, landforms, and landscapes to get our brains warmed up for thinking about coastlines. In this specification, we're always making those connections. Thinking about things as a sequence is really important. We think about what processes do we have acting in an area. We think about the landforms they create, and we think about how the landforms combine to make landscapes. So the processes we're thinking about are weathering, as you just saw in the bubble quiz, erosion, transportation, deposition. They're going to vary according to lots of different factors. It could be the nature of the waves. It could be the geology of the coastline that's going to affect the landforms that are created by these coastal processes. And then, as I said, when it talks about a coastal landscape, we're talking about the landforms that combine in one area. Often students get thrown by that when it says a coastal landscape, but we're just thinking of in an area, like loads of you were doing the big shout outs for Flamborough just now, wonderful coastline. And when we're talking about the coastal landscape there, we're thinking about that combination, how we've got there, we've got the wave cut platform, we've got the cliffs, we've got the stacks, the arches, they all combine to create that coastal landscape. So over now, I think, to Brendan for a bit of high and low energy coastlines.
Thanks, Catherine. So we were talking about energy earlier on in the bubble quiz, and there are basically, 2 kinds of coastlines if we consider the amount of energy going on. In a moment, there's going to be a categorise activity. So if you do have a piece of paper and have that ready, just for a few moments' time. So I'm just going to, as a preamble to that, just make sure we know what these 2 different types of coastlines are. So higher energy coastlines, they're well known for rocky cliffs and headlands, typical of what you might see in places like Cornwall, the west of Ireland, some to the west of Scotland. They're quite dynamic, powerful waves are eroding the cliffs, and they change them and create a spectacular, quite often quite spectacular landscapes. Low energy coastlines, which was the one I said I would be my favourite one, like in estuarine environments, they're quite sheltered, so they have landscapes which are perhaps dominated by depositional landforms. They can often be more stable, and deposition is more significant perhaps than erosion, but erosion will still occur. But then, of course, they do change with time. In both cases, it's important to think about dynamic equilibrium and feedback loops. Okay, so if we move on to the next slide, we're thinking about in the context of dynamic equilibrium, sediment sources, cells, and budgets. And it's very important here that we consider the coast as a system. It is a coastal system with inputs, transfers, stores, and outputs. So material that's eroded from high energy coastlines can often then become sediment in the coastal system, is transported, i.e. transferred by waves, potentially moving out to sea or along the coastline, what we call longshore or littoral drift. And sediment can be deposited along low energy stretches of coastline. The sediment then circulates within cells, and around the coastline of England and Wales, 11 primary sediment cells have been identified. I'm sure you will have seen maps featuring those. And these are near to, they're not actually, but they're close-ish to what we might call closed systems. That's why they've been designated that way. The sediment budget shows the balance between the volume of sediment held within a system and the volumes entering or leave it. So as stated earlier, it's always useful to think about coasts through the lens of dynamic equilibrium and feedback loops. Okay, the activity is coming up, the categorize activity. So it's quite straightforward. You have 60 seconds to separate the key words on the right-hand side into two categories. So you can just write high on one side, low on the other, and you don't have to write the full word, just write the numbers. So you have a minute, off you go. Okay, well done everybody. I could see quite a few good answers coming through there. The correct answers, if we take a look at them, are as follows. So in the high energy coastline, we have 6, 8, 2 and 5, or 2, 5, 6 and 8 if you gave them the correct order of their numbers. And the low energy coastline, 1, 3, 4 and 7. So high energy features erosion, cliffs, powerful waves, and dynamic. The low energy coastline will be deposition, beaches, sheltered and stable. That doesn't mean that the low energy coastline isn't dynamic, but the word might, perhaps reflect the fact that in the high energy coastline you have a little bit more, spectacular change, if you like. Okay, let's move on to the next activity.
Right. Okay. So back to some landforms, and you're doing absolutely fantastically there, answering those questions. Well done. So we're going to think a little bit about landforms now, and landforms in some ways are quite nice to look at A-level geography because it is, building very much on your GCSE geography. But remember, a big difference about the GCSE and the A-level is that GCSE, if you study the AQA specification, you'll have looked about UK landscapes. And when we're looking at the A-level specification, we're looking at things globally. So we've got the high energy coastlines that Brendan was just talking about so brilliantly. They have the characteristic landscapes of erosion, and they have combinations of landforms which might include cliffs and wave-cut platforms. You might also have cliff profile features, including caves, arches, and stacks. And when I asked about the your favourite coastlines earlier, some people were putting Old Harry. So, of course, Old Harry down at Swanage is a fantastic example of headlands where you've got the caves, arches, and the stack of Old Harry himself. And they're created by erosional processes such as hydraulic action and abrasion, but they're going to vary because of the geological structure. So the geomorphological processes are acting on the coastline, and the landforms that are created depend on the rocks you've got there. So when we're talking about Old Harry, we're talking about the chalk, and also when we're talking about Flamborough Head, again, we're talking about almost, quite similar types of materials, these resistant to erosion, which can have these, sharp cliff edges and won't be like the clays that would just sort of slump and slide down. So all the time we're thinking about the processes, the context that they're happening in to create certain landforms. Now, of course, we've got landforms of coastal deposition as well. And low energy coastlines, again, will have characteristic landscapes. And these will be created by combinations of depositional features, such as beaches. We also need to make sure we know about simple and compound spits, tombolos, offshore bars, and barrier beaches and islands. And then slightly different, but still looking at deposition, we have sand dunes, because of course when we're looking at sand dunes, we're thinking they are slightly inland, and so they are going to be depending on the transportation through the wind, through the aeolian processes, rather than being so much to do with the action of the waves. And again, this process of deposition would depend on the context. It would depend on the sediment supply, as Brendan mentioned earlier. It would depend on the shelter. It would depend on whether you've got a river which is coming into the sea. So many different things that you need to be thinking about when you are considering the landscapes in a particular location. Now, to throw in a little bit of spice, when we're talking about coastal landforms at A level, we also look at coastlines of emergence and submergence. So this isn't something you do at GCSE. This is something where we're thinking about change over geological time. And with coastal landscapes, they might be influenced by eustatic sea level change, which is to do with the sea level itself, that can get higher or lower according to the global temperatures. So if we are at a time like we are now, where things are getting warmer, we've got the ice is moving from the cryosphere into the hydrosphere, and we've got the sea levels rising. We've also got isostatic changes related to sea level, and this is where we have the land moving in relation to the sea. So, for example, an area that in the past was glaciated and the glaciers melted, that is going to start to rebound, and it rebounds very slowly, but it will rise over time, and that will affect the relative sea level between the land and the sea. Now, sometimes we get tectonic events which can cause sea level change. And the Haiti earthquake was an interesting example of this, with the island almost like tilting, with coral reefs being exposed on one side and the other side being submerged. When we're thinking about these landforms that come from these processes, so remember, we're always thinking about processes leading to landforms. We can have landforms of emergence, such as raised beaches and marine platforms. But we can also have landforms of submergence. We've got rias, where we're thinking about a submerged river valley. We've got fjords, where we're thinking about a glacial valley that's been submerged. And then Dalmatian coasts, where you've got a series of valleys that run parallel to each other, which have been flooded, like we get on the Dalmatian coast in Croatia. So we've got a series of multi-choice questions for you now, and I'm hoping some of your favourite coastlines will be appearing because several people did a shout out for beautiful Flamborough. And so let's see, can you tell me, looking at this picture, what is this called? Right, absolutely brilliant. Ricky saying A there, that's brilliant. Okay, let's see the answer, John. Right, wave cut platform. Sam's saying that as well, and Molly, brilliant. So I love that picture there. That's one I took on my Easter holiday last year, and you can see that extensive wave cut platform that has been created as the cliffs have been retreating. Okay, on to the next one. Right, another of my holiday snaps. So what limits the height of this notch? So you can see in the stack that we've got in that picture there at Ladram Bay in Devon, you can see that it has got a wave cut notch at the bottom. I think I might have just given away the answer. So what is going to be limiting the height of that notch? Right, oh, we got some different answers now. We've got a few different ones. Yeah, we got Izzy with B, Molly with C, Vanessa with B. So we've got some different ones there. Let's see the answer. Right, brilliant. Oh, well done, Orlando. Very good. And Quacker. So you're going to have a limitation there on the height of that wave cut notch because of the height reached by the waves. So in that picture, you can see that the wave action is affecting the lower part of that stack, and then the upper part of that stack is going to be being affected by weathering processes. Fantastic. On to the next one. Right, okay, so back to Flamborough again. So what process operates at the top of this arch? So think about what's going on up the top there. So if you haven't been to Flamborough Head, I really recommend going there. Absolutely fantastic coastal landscape there. Thank you, Alice. Says that the holiday snaps are good. Right, okay, so we've got again, we've got a bit of variation here. We've got some hydraulic action, people are saying, but most people are saying weathering. So let's see the answer. Well done, Tobias and Roman there. Fantastic. So yeah, so we're looking here at weathering because we've got the waves aren't going to be reaching right up to the top there. So the waves are going to be affecting the lower bit. You can almost see by the discoloration there how high the waves are getting. And then we've got the bit above affected by weathering. Somebody just quickly, they said, what's the definition of a wave cut platform? A wave cut platform is that fairly flat area of rock which is left behind as the cliff retreats. So there will be a wave cut notch. The top of the cliff will eventually be undercut and will fall down. The cliff retreats back and it leaves behind that wave cut platform, which sometimes is exposed, as in the case of the one at Flamborough Head there, but sometimes that will be covered by a beach. Okay, on to number 4. Right, so good old Flamborough again. So sometimes you may need to consider how things are going to change over time, how landforms, landscapes going to change over time. How will this landform change over time? So, right, brilliant. Yeah, Roman coming straight in there with C. Lots of people there. Rain, Ella, Aidan, fantastic. Storming through. Let's see the answer. Right, yeah, eventually we're going to see this stack changing into a stump. Okay, on to number 5. Right, so while I was still on my holiday up in Yorkshire, also went to Spurn, but what type of landform is that? So that's the little information board I got to see there before I went on a walk all the way to the end. So, right, brilliant. Okay, Wriggle and Warren and Katie... Oliver, fantastic, absolutely storming along there. So they think it's a spit. What is the answer, John? Right, brilliant. Yeah, we have got a spit there at Spurn Head, and stunning to go and visit. Okay, on to number 6. Right, okay, so we have got another picture there of Spurn in Yorkshire, and this picture gives you a bit of a clue what is likely to happen to that over time. If we had a large storm, what is going to happen? There are clues in the picture there. Right, okay, I think people are looking at the picture there really well. Well done, Ryan, and well done, Neve. So let's see the answer there. Yeah, so you can see in that picture, you can see sort of like looking at the top of the picture that there's a really narrow bit in this bit, and in a large storm we could see that being broken through. And in fact, that area does get covered over by water when you've got the high tide. So even though this is a depositional feature and is in a relatively sheltered environment, it is, as Brendan said earlier, it is still dynamic. It can change, and a big storm could make all the difference. On to number 7. Right, okay, so we have some shout outs for good old Harry. So there is a picture that I've taken. Why is geology important in the formation of this landscape? Have a little look and see which one you think it is. Right, so we're getting some different answers coming up here. Right, okay, so we got some C's, we've got some A's. So old Harry down on the Dorset coast near Swanage. Let's see the answer to this one. Right. Okay. So quite a few people said chalk erodes rapidly. That can be a misconception. Chalk may be brittle when you've got a stick of chalk and you can snap it easily, but it's actually, as a rock, it is very hard, but it has cracks in it. And so what happens in the case of old Harry is we've got cracks in the rock, which then get eroded by the waves, and those will get wider, forming a cave. And then we get this sequence, which is going to create this sort of landscape on a headland. So think carefully when you're revising about geology, about the different types of rocks and their characteristics. So I think we've got our last one now. So this was a picture I took when I went away last summer to Norway. Really recommend it. And what is that landform called? So remember, we talked a little bit about submergence, emergence, and happening in different places. Right. Okay. So well done. Sam saying B there. Aidan also saying B, and Roman. Brilliant. Molly. Let's see what the answer is. Right. Yes. So we know that this is a fjord rather than a ria by the very steep sides. If we were looking at a river valley, so a good example of a ria is Foy down in Cornwall, and that's where a river valley has been submerged. Here you can see we've got that glacial U-shaped valley which has been submerged and creating that rather beautiful fjord. So Claire's just asked difference in a landscape and a landform. A landform is when we're looking at something like the stack that's Flamborough. When we look at those landforms together, the cliffs, the stacks, the wave cut platform, the arches, we're looking at that very distinctive landscape in that location. So landforms combine to form a landscape. So processes create landforms combine to create landscapes. So we've been talking a little bit about sea level change. So over to Brendan now to think a little bit more about climate change.
Many thanks, Catherine, and loads of fantastic answers there. Well done. So we're looking at, I suppose, what might be described as geography in the news here. Geography is quite often something which I would say 70% of the time you've got news stories which are linked with geography, and climate change is often in the news, including today, which I'll mention in a minute. So the climate's warmed by around 1.5 degrees since pre-industrial times, and that's a fact. The IPCC has created different scenarios. You will have studied these different scenarios, different predictions, if you like, of how things might pan out in the future to show how warming may continue in the future, depending on how much carbon emissions are emitted. So just today it was announced, in fact, that, and I'm reading here from the BBC website, fueled by climate change, the world's oceans have broken temperature records every single day over the past year. And that's today's news. So there are implications. The second point here is about the implications for coastlines. So that we can expect rising sea levels, obviously, but also high energy storms, strong winds and waves, low pressure systems, which we've had over the last few weeks to bring storm surges, changes in the seawater temperature, and acidity affecting coastal currents and ecosystems. Today, for example, was the 40th anniversary of the Thames Barrier, which is there to protect London from a storm surge. And there's also been concern in the news today about the impact on coral reefs of climate change. So that all of these things are very, very current. In that regard, we're going to look at a couple of news headlines where there will be missing words. So you do have to, if you want to, type in the chat, type something a bit more than one letter, but not too many letters, and they will need to be geographical terms. So the first one, second massive something in 48 hours on the Jurassic Coast poses danger to holidaymakers. What could the missing word be? Have we got geography news for us? Some quite good suggestions here, because it's difficult to perhaps pick the exactly the correct one. So let's look at the correct word, which one of the people have got, or very similar, which is rockfall. Okay, so that's the second massive rockfall in 48 hours on the Jurassic Coast. That's Dorset. Okay, let's look at the next one. Storm Babette caused 5 years worth of something in 2 days along a Scottish coastline. What could that something be? It's got to be a geographical term. At least one person, 2 or 3 have got it. So congratulations to Sam, Katie, and Vanessa and Aidan, because the word, and other people as well, apologies if I didn't mention your names, erosion is the word that's missing. And this is to do with Storm Babette in October last year, where huge amounts of damage were incurred along the Musselburgh coastline in East Lothian, where 4,000 cubic metres of sediment was removed from beaches. That's equivalent to 5 years' worth of erosion in some places. But of course, the coast being the coast, sometimes that material will be replaced, but not always, because it's a dynamic coastline. Now, if we just look at this in another sense, we've got the relationship between these things, between process time, landforms, and places. So coastal processes occur over different timescales. So mass movement can be very rapid. Subaerial weathering will change the coastline more slowly. It's a little bit like with your school bag. Parts of it will wear out very slowly, almost imperceptibly, but then sometimes you'll get dramatic changes like the handle falling off. So both of them wear out the school bag. It's just they do that at different rates. Processes operate over different timescales, and they combine to create distinctive landforms. So an arch may be weathered on top and more rapidly eroded at its base, and then succumb to rapid mass movement when it collapses. Very famous example of this was you may have heard of the Azure Arch in Malta, and it collapsed very suddenly on March 2017, which upset an awful lot of people, not least the tourist industry in Malta. And since then, there's been a very serious but controversial proposal to rebuild it as a massive steel sculpture, and they're going to call it the Heart of Malta if it ever happens. So that's how important these things can be. So the combination of landforms creates what we call the coastal landscape. Back to Catherine.
Okay, so we are going to be looking now at the first case study. So there are 2 case studies for the coast topic. However, you will probably have lots of little examples that you studied throughout the course, and it's really good to know a nice variety of different coastal landforms, landscapes in different contexts. But we've got a case study requirement of knowing about a coastal environment at a local scale. So you should have an example, which, in my case, I teach in Burnham-on-Sea. So we study our coastline, which is in our local area. But local scale means that you are looking at it at that sort of, close-up view, getting to really get to grips with what is going on in terms of the processes and in terms of the management. So we're going to have a little activity now. We're going to do a little devil's advocate activity, because when we're looking at the local case study, we need to think not just about the processes, but we need to think about the management as well. So we've got an argument here. Coastal engineers believe that our coastlines can be protected by adapting to the challenges of climate change via hard engineering. Seawalls can protect us from coastal erosion and flooding as sea levels rise and storms become more intense. So have a little think about this. It says, however, if you were going to argue against this, what would you say? Now, obviously, in the case of your case study, you are going to be relating this to a specific context. But generally, if people are saying seawalls are going to do this, they're going to protect us from flooding, they protect us from storms. How could you argue against that? Let's have a look at some suggestions in the comments box. Right. Okay. So yeah, Oliver's already said about the financial cost. Not everywhere is going to be able to afford the expense. We've also got the need for maintenance. Well done, Vanessa. So yeah, you can't just put it there and walk away. You need to be thinking about the long term. Yeah. Right. Excellent. We've got the cost and the damage to the ecosystems when it's installed. You guys are amazing. Fantastic ideas here. Right, brilliant there, Harry. I love the way you're saying it's only prolonging the situation. You are saying that, you know, we're just holding things up. So let's see which arguments I've got popping up on the screen there. So yeah, so expensive, a lot you talked about. It's only going to protect coastlines for a certain amount of sea level rise. Coastal defences that were built in the past. The one in Burnham-on-Sea was built 40 years ago. It's coming close to being overtopped. And climate change is going to be continuing to cause issues despite adaptations. This is something that we're going to have to think about in the long term. There is no quick fix. Right, absolutely fantastic suggestions there. So let's have another look at another one. So researchers have suggested that changes to the salinity and temperature of our oceans would in turn change ocean currents with a significant impact on our coastlines. For example, the Gulf Stream, which affects the west of the UK, is weakening. So we've got people saying that because we've got more fresh water coming into the ocean systems, that is going to affect coastlines. So again, I study Burnham-on-Sea with my students. We have the Gulf Stream that is affecting us. So how could we argue against this argument that we've got here? So, right, okay, so we've got here one comment here, but I think a lot of you are getting a little bit stuck on this one. Okay, John, let's see some answers. Put people out of the misery. Right. So the thing is that when we're thinking about the changes in the ocean currents, we cannot predict the timescales over which this is going to happen. We cannot say for the different coastlines at local scales exactly what is going to happen where. And also, there are some people that are arguing, saying, well, actually, you know, we have got these changing happening, but people can overcome the problems that have been caused with technology and the human initiative. So, yeah, Ricky's saying there about not knowing about ocean currents. It's worth having a look at the ocean conveyor. So we've got the currents moving around the world, which are on some on the surface and some deep down low, and those are driven by temperature and salinity. And then what we're looking at in this example, thinking about the local case study, is you would think about how things like this could be affecting the coastline you're studying. So like I say, I study Burnham-on-Sea with my students, and we are definitely a place which, with changes to the Gulf Stream, we could see changes which affect our coastline. Yeah, someone's just said, do we do ones for Edexcel? We're doing ones for AQA, but they will link in also for Edexcel and for other specifications. There is a core content that all A levels have to include. And so you should have like some really good information for all of the specs coming up in this, even though we are particularly focusing on the AQA specification. So yeah, so basically this whole idea, counter arguments. Oh, the idea of counter arguments is really important. I was just going to say, going to hand over now to Brendan for the other case study and more arguments.
Yeah, that's not me making that noise, I might add.
You sure?
So the case study that you have to know about as well is one that's beyond the UK. So perhaps harder to relate to, perhaps less likely to have visited it. The one we're going to look at here is about Bangladesh. for a couple of reasons. One is that because it links with something that you might have studied anyway, which is a coastal ecosystem, but also because there is another resource, a bit like this one, that's free, that we recorded about 3 years ago, and we'll give you a link to that at the end, and it goes into some detail about this case study. So if you happen to know that case study, we need to go back one there, John, for a second. I'm just going to explain a little bit about this case study, just in case you don't know anything about it. So it's quite a popular one, and it's the Sundarbans of southern Bangladesh and India, and it covers an area of about 10,000 square kilometers. So it's a low-lying area in the Ganges Delta. So the water from that is going to flow into the Bay of Bengal. The land area there is characterized by very salt-tolerant mangrove forests, or haloceres. That's, salty environments, which provide an important habitat for all kinds of different creatures. One that would be, a big fauna that you might have heard of would be the Royal Bengal tiger, but there are also swamps and sand dunes, or what we call samoseres. So one of the schema that we offer you in the other resource is a way of thinking about this called KORRMA, KORMA, which is key characteristics, K for key characteristics, O for opportunities, R for risks, R for resilience, M for mitigation, and A for adaptation. So that could apply to another case study as well, a little way of thinking through and giving a structure to your revision. So we're going to look at one particular aspect of that now. So if we look at the on balance, a question could be, explain why mangrove forests are being restored along many tropical coastlines. So just to start off with, just jot down any advantages that might happen as a result of restoring mangrove forests. What would be some advantages of doing that? We're just going to give you a few moments to think about that. So jot down your ideas on paper, and if you feel brave, in the chat. Some good ideas coming through. We won't necessarily cover all your great ideas in our evaluation here, but some of these will be very, very good to consider. Okay, some very valid ideas coming through there. Let's just have a look and see what a couple of the advantages would be. So, first of all, they absorb the energy of storms and promote deposition. And I think somebody mentioned that they can absorb the energy from tsunamis. That's very true. Mangroves can be used to mitigate against the risk of coastal flooding and erosion with sea level rise, and that's clearly a threat going forward for low-lying countries like Bangladesh, because the more energy there is in the atmosphere, the worse the tropical storms in that area are likely to be, coupled with the fact you've got more water flowing down from the Himalaya through those rivers. So those two factors can be problematic for Bangladesh. Okay, now jot down some potential disadvantages of restoration, of mangrove restoration. Just give you a moment to think of some disadvantages, and as I say, feel free to put them in the chat if you like. Any disadvantages, perhaps more difficult to consider? Okay, just before we go on to those, a couple of people catching up on some of the advantages. Somebody mentioned the fact that the mangroves act as fish nurseries. That's very true. That's a very good advantage as well. So let's look at the disadvantages. So the disadvantages, they may obstruct the sea views that tourists expect. Oh dear, that wouldn't be good, would it, for the sea views? Mangroves make it harder for people to access the coastline. They're notoriously difficult to walk through or to wade through. So if people want to use beaches, that could be seen as a disadvantage. And it has motivated, in some places, the removal of the mangroves. Now, clearly, that's got a lot of problems associated with it. We're just trying to think of, why have they been removed? So that could be a question that might be something like, explain why the people in the tour industry may be in favour of planting the mangroves along the coast or not. That's the kind of question. Another thing to consider there, a good framework to consider for this is, what are the ecosystem services that mangroves provide, such as provisioning things, food, for example, regulating, water purification, carbon sequestration, supporting services such as nutrient recycling, and of course cultural services such as recreational or even spiritual services. So ecosystem services is a good thing to bring into this dimension as well. So thank you very much for your great ideas. We're back to Catherine now.
Right, wonderful. So where are the coast questions in the exam paper? Well, if you're doing the AQA specification, you're going to find the coast questions in paper 1, which is coming up pretty soon, and it's section B. So this is a section where there are 3 options. So you've got you've got the water and carbon question out the way, and then you've got a choice in section B of hot deserts, coastal systems, or glacial. So what you are going to be doing is answering about coasts, if that's what you've studied. This is a very popular option, and you will have a 4-mark question, which will be about knowing something. It's going to be those AO1 marks. You need to be thinking about that being point marks, making 4 points or making 2 points that are each developed, so you can get those 4 marks. Then we have 2 6-mark questions, the first one being marked for AO3 skills, and so that's where you're given some information and asked to analyze it. And the second 6-mark question will be marked for AO1 and AO2, so that's your knowledge, understanding and application. And then the final bit of the coast section is the 20-mark question. So let's have a little look at an exam question. So this is the sort of question you may have come up in your end of your coast section. So we've got there: assess challenges presented by recent and or predicted climate change to sustainable management of a local coastal environment you studied. So remember I said about you've got to study a local coastal environment, you have your case study, and then that is going to be something you're going to be using in this answer. So let's break this down a bit. So first of all, the command word is assess. So assess the challenges. So we're thinking, how important are they? Which are the most serious challenges? Which are the challenges that maybe aren't as significant? So command word is assess. What else have we got here? So what are we assessing? Well, we're assessing the challenges presented by recent and or predicted climate change. And we're doing this in the context of management. So you should have, in your case study for your local area, you should have looked at the management, sustainability in the management, and be thinking about what's happened recently and what's likely to happen in the future. And then what's our context we're doing this in? So we're looking at a local coastal environment that you've studied. Now, remember, don't just tag that on the end. You need to have that all through your answer. So over to Brendan for some exam gold.
Thank you, Catherine. So we've talked a lot about case studies and referring to examples as well. Case studies, students often kind of think, well, I've really got to learn my case studies. And then when I talk about them, I've got to tell the examiner everything I know about them. That's not always the case. There can be some times when you go into depth, but there can be other occasions when it's more appropriate to just include them as examples in a very brief way. So you have to aim to include the information that's appropriate to the question. But embedding examples does really help to show how you can apply your knowledge to what we call novel situations. And that's always the challenge, particularly at A-level as compared with GCSE. How can you look at a novel situation and apply what you know to that? Okay, we mentioned earlier on about the other resources. You can see there we've got 3 links, and the resource I was referring to, the CORMA for case study, mnemonic, is in Revision Blast Coastal Systems and Landscapes 2, but the other 2 resources there are incredibly useful, so please do refer to those. and we hope that your revision goes extremely well.
Indeed, we do, Brendan. Thank you. Massive. That is a few thanks before we go through the final bit. Huge thank you, of course, to Catherine and to Brendan for delivering those activities. Huge thank you to Catherine for all the photographs as well. So what a wonderful set of holidays you must have, Catherine. Of course, another big thank you to everybody who's responding. I'm sure Brendan and Catherine will agree with me. Some really outstanding responses tonight. So it bodes very, very well for the exam, which, as we quite rightly say in the chat, is not very far away at all. Just a quick reminder, 1 or 2 questions again turning up in the chat as we were going along. In a few moments' time, I'm going to press a finish button. This recording will finish, and then this becomes a replay. So if you're looking for the PowerPoint that we've been using tonight, search on the Tutor website under the replay section of live streams, and you'll find us very soon towards the top. And you can have a look at the presentation and of course watch this video again. If you have found tonight useful, please do give us a thumbs up in the YouTube window there. That'll help us get our message out to everybody else. We're back on Monday. I think we're looking at hazards on Monday. If anybody's doing hazards alongside coastal landscapes, we would love to see them. If we don't see you before your exam though, from Brendan, from Catherine, from myself, the very, very best of luck. Thanks again for your contributions, and see you again very soon. Bye-bye, everybody.
Bye.
Bye.